Hi friends, this video is meant for people who do not have a clear idea about irrational numbers. Let me try to make it as simple as I can. Before getting into what an irrational number is, let me begin with rational numbers first. Hopefully this will give you a better understanding of irrational numbers. A rational number is a number which is expressible in the form P by Q, where P and Q are integers. This is the definition of a rational number. Any number expressible in the form P by Q, where P and Q are integers. Basically, this means all kinds of fractions. Now, I refer to integers here in this context. So, let me clarify what an integer is first. If you take a number line, say, let me mark 0 somewhere here. On the right, I am marking whole numbers like 1, 2, 3. To the right of it, 4, it will go on like that. And to the left of 0, I am marking -1, -2, -3, etc. These are whole numbers. In fact, the definition of whole numbers is 0, 1, 2, 3, etc. These are called positive integers. Numbers to the right of 0, 1, 2, 3, they are called positive integers. There is another name for positive integers. That is natural numbers. Maybe you heard of these terms before. So a natural number is nothing but 1, 2, 3, etc. These are called negative integers. So what do you do with 0 here? 0, that's singleton. Singleton means a set of just one element. This is considered neither negative nor positive. It has an existence of its own. So basically integers is a union of or collection of three sets: positive integers, negative integers, and singleton 0. So I hope you got an idea about integers. So rational number is a number which can be put in the form P by Q, where P and Q are integers. Now look at this number. If I write just 5, is it a rational number? Yeah, it's a rational number. It's a positive integer and 5 is just 5 by 1. So every integer is a rational number. Rather, integers form a subset of rational numbers. Now take another fraction, 2 by 5. When you put this in the decimal form, what do you get? 0.4. So 2 by 5 is a rational number because it satisfies the basic definition of a number in the form P by Q, where P is 2 and Q is 5. And when expressed in the decimal form, you are getting 0.4. Now let's look at another rational number, 1 by 3. What do you get when you put it in the decimal form? 0.333. It goes on. It will never end. For calculation purpose, of course, you take approximations, but the real value, it goes on. So what is the difference between these two rational numbers? 2 by 5 and 1 by 3. 2 by 5 is a terminating rational number. Terminating rational number because it terminates here. Whereas if you look at 1 by 3, which is also a rational number, this is a non-terminating rational number. So what you observe here finally, rational numbers can be both terminating and non-terminating. And if non-terminating, there is something else you can observe. You see the same number being repeated again and again, 3333. So this is a non-terminating rational number, but repeating. Can you see that? Repeating after every single digit. Now let me consider another rational number. Say, let me write the number first. Look at a number like this. 252525. It goes on like this. This is also a rational number, but this is a non-terminating rational number. So when I say this is a non-terminating rational number, definitely that can be expressed in the form P by Q. Can you tell me? Can you guess? It's very simple. You write like this. 25 by 99. Word 99 indicates what? See, I'm putting just 2 nines because in this non-terminating rational numbers, you can see repetition after every 2 digits. So there is a short form to write this rational number. You write it like this, indicating 2-5 repetition will go on. So to convert this kind of non-terminating rational number into P by Q form, you just write 25, then divide it by 99. 99 because there are 2 digits. Supposing you have a look at this number, say 3 327, 327, non-terminating. This is also a rational number. It's a non-terminating rational number. And what will be the fractional equivalent of this number? It will be, see, in short, you can write it like this: 327 bar, indicating 3-digit repetition, and the fractional equivalent of this number is just 3 nines. You may verify these things for yourself by putting it in your calculator. You just type this number in the calculator, you will be getting this. Similarly, this you type, you will be getting this. So you are just writing a few nines in the denominator, and the number of nines will equal the number of digits in the repetition. 3 digits means 3 nines. 2 digits means 2 nines. Supposing you had 4-digit repetition, you will be writing 4 nines. That's all. It's as simple as this to convert a non-terminating rational number into fractional format. I want to add a few more things in the rational numbers before taking up irrational numbers. Rational numbers, as I showed here, if non-terminating, it will be repeating. I have shown a few examples for that. Now there is one more different kind of rational number. Let me share with you that also before looking at irrational numbers. Look at this number, say 3, 5, 4, 5, 4, 5, 4, etc. See, this is slightly different from the non-terminating rational numbers I discussed before, because there is a repetition here, 2-digit repetition in fact, but there is a number 3 coming before that. Can you see that? In short, we write this rational number as 3, 5, 4, and I put the bar here, 3 excluded. That means these are non-terminating rational numbers with the 2 parts, one repeating part and then there is a non-repetitive part. This number also you can convert into P by Q format or the fractional equivalent. How do you do that? This is the way to go about it. You write the whole number first, 354, then subtract the number formed by the digits in the non-repetitive part. There is only one digit, so the number is 3. When I say number formed by the digits in the non-repetitive part, there could be 1 digit, 2 digits or 3 digits, or in short a few digits before the repetition starts. So whatever number of digits you see here, you write a number corresponding to that, 3. In this case there is only 1 digit, so I am writing 3. You got the numerator. Denominator, you will be putting a few nines and zeros. The number of nines you put here will equal the number of digits in the repeating part. How many digits are there in the repeating part? 2 digits. So you just write 2 nines. Then you will be putting a few zeros. And the number of zeros you put here will equal the number of digits in the non-repetitive part. There is only 1 digit. So you put just 1 zero. Supposing you had 2 digits, you will be putting 2 zeros. Okay, then you simplify this. 354 minus 3 is 351 divided by 990. You just put this number in the calculator, you will get this number. So we have dealt with all kinds of rational numbers. Like I showed you here, terminating rational number and also non-terminating rational numbers. And the non-terminating rational numbers can be of different kinds. We have covered all kinds of rational numbers. What is the final observation you can make here? Rational numbers you can broadly divide into terminating and non-terminating. Terminating, I showed you one example. I can show many examples. See, you take 1 by 4. If you convert this in, that will be just 0.25. It ends there. It doesn't go on. Whereas non-terminating, I have shown you a lot of examples. And if a rational number is non-terminating, definitely that will be repeating. The only thing is that sometimes the repetition starts straight away after the decimal point. In a few cases, the repetition may start after a few numbers without repetition. A few finite number of numbers before a repetition starts. One example I showed you. There are many such examples. I give below the description of a video where you can see many such examples for further reference. Now you concentrate on this. Rational numbers can be non-terminating, but it will be repeating. Now I will show you some numbers which when expressed in the decimal form will be both non-terminating and non-repeating. See, in all the examples I discussed before, you had numbers which were non-terminating but repeating. But there are a few other numbers which on conversion into decimal form will be both non-terminating and non-repeating. Such numbers are called irrational numbers. So for a number to be irrational, there are two characteristics to be satisfied. One, it should be non-terminating, and the other non-repeating. I'll give you a few examples for these kinds of numbers, which will help you get a better understanding. See, you might have seen numbers like square root of 2, square root of 3, or even square root of 5. All these numbers, these are irrational numbers because on conversion of these numbers into decimal form, for which you just find out the square root of 2. Square root of 2, just put it in your calculator. You will get the number as 1.414213562373. It will go on like this. Again, use your calculator to find out root 3. This is going to be like this. Yeah, my calculator gives up to this and thereafter it goes on. So look at these numbers. What do you observe here? These numbers are non-terminating, but you don't see any repetition unlike the ones shown to you before. See, numbers come in all irregular ways. There is no repetition in both the cases. So root 2 and root 3 are irrational numbers. And there is one more thing to be noted about these numbers. When you have a number being both non-terminating and non-repeating, such numbers you cannot convert into fractional form. That is, you cannot express these numbers in the form P by Q, where P and Q are integers. In fact, for the conversion of non-terminating but repeating rational numbers, there is a strategy we use for the conversion, which I have not dealt with in this video. The point I am trying to make is those strategies you cannot apply to these numbers and convert those numbers into P by Q form. And such numbers are called irrational numbers. So basically, irrational numbers you can think of this way. Numbers which are non-terminating and non-repeating when expressed in the decimal form. Number two, these numbers cannot be put in the form P by Q. That is what you need to understand by the word irrational numbers. I hope you got a clear idea about irrational numbers. If there is any point you want me to further clarify, leave your remarks in the comments below. And if you got a clear understanding of irrational numbers, please hit the like button and subscribe to my channel. And also don't forget to press the notification bell so that you will be getting many more interesting ideas in maths in future. Thanks for watching and see you in the next video.